Good afternoon. This is Florian from Visicon. Thanks for joining today's webinar on how to improve project outcomes with better model review and checking. I'm going to wait another minute or so before we get formally started, but just want to make sure that the sound and everything is coming across. And I assume all of you can see my screen at this point. So we'll get started in just about a minute. Great, it's 1 p.m. Eastern time. Again, this is Florian calling in from New York. I welcome everybody to today's session on how to improve project outcomes with better model review and checking. This should be a fun session. I'm going to go through three basic use cases, and we'll try to keep the session to as close to 30 minutes as possible. Let's start out with just talking about what is Visicon. Visicon is the smarter model review and checking solution firms are relying on to improve how project teams access and use model data. So what are some of the benefits they're deriving? First of all, it gives access to all 3D models for everyone on a project. It allows for less time spent critical project information. And it leads to faster and better internal quality control procedures. And all of those combined ultimately lead to improving overall project outcomes. So that's really what Visicon is about, is driving essentially a more efficient way for project teams to work with 3D model information and deliver better projects. So then the question is, when would you use Visicon? So a simple example is, to clarify complex geometry that's not clear in 2D plans. I recall about a week or two ago, I think 3 or 4 of us were on a Zoom call, and we were kind of flipping back and forth between a whole bunch of PDFs trying to decipher exactly how a particular complex geometry was put together. And we just jumped over to the Visicon 3D model and were able to resolve the issue instantaneously, whereas we were just all scratching our heads trying to figure out what's going on, just relying on the 2D plans. Then we also see the use for facilitating project coordination meetings. So this is more intended for, let's say, or where we're seeing great use of this is for internal project coordination meetings, where, let's say, you don't necessarily need to or want to publish everything to a central, let's say, BIM 360 platform where everybody on the project can see it, but you really just want to be able to quickly huddle and dig into project information and address, quick issues when it comes to, a team meeting. So that's really where it has great applications. And then I'll go through workflows, but it's very useful for just simply identifying when your design models have changed. Today, it's not very easy to be able to identify it, or I talk to a lot of our clients and they're still spending lots of time going sheet by sheet on, reviewing PDFs using Bluebeam. And once they switch over to, reviewing model changes across the whole model, they tell us it's much, much more efficient. Implementing standardized quality control protocols. So again, right now, more and more reliance is being placed on the actual 3D model information, but how do we really have solid controls of what data is being modeled? You're not always modeling the information yourself. You're relying on external partners and different people within your team. How do you standardize or streamline that process of understanding what's in models? And then lastly, just simply to communicate specific model issues. Yes, Bluebeam is fantastic for marking up a lot of things in 2D, but sometimes it's a hell of a lot more efficient to be able to just pull up a detail in 3D and being able to mark that up. And that's one of the things that Visicon does. So what will we cover in today's session? As I alluded to, we're going to go through 3 specific workflow examples. The first workflow example is going to be how to the smarter way to review 3D models. So that's more of a general overview. Then we're going to talk about 2 specific cases, how to standardize QC with what we call view templates across different model types. And then lastly, how to manage model changes. And that should be, well, all of them are exciting, but I particularly like what we can offer in terms of, how to automate model changes. As you probably noticed, you're all on mute. What will happen is at the end of the session, I'll stop. I'll leave plenty of time to stick around for Q&A, and then you can just type in your questions online, and I'll go through those and respond. So let's go through the first workflow. And so this is just to highlight how Visicon can be used as the smarter way to review 3D models. What models are we talking about? We're talking about project models like REVIT models, right? So more and more, I would say over 90% of our clients, or when I say clients, my former ADAPT clients, when I ask them how are they producing their 2D documents, they're almost all now moving to REVIT. So there's a lot of embedded 3D information in REVIT models. By IFC, that covers the gamut of everything else, whether it's a STAD model, ArchiCAD model, TEKLA model, all of those typically just use IFC as their exchange format. Point clouds, ETABS models that's quite popular for structural models, and then because of my ADAPT DNA, obviously we have to make sure we can support ADAPT models as well. And again, Visicon allows you to efficiently view each of these models in a consistent way, independently, or merge them. And we're going to do some fun stuff with that in the second workflow. So why does that matter? It matters because currently you have to be, you have to have a license of those authoring programs that I showed. Secondly, you have to be pretty adverse or an expert at being able to open and navigate those models. And to be frank, as powerful as REVIT is, it is not a really, really good tool or conducive to just simply opening up a model and trying to navigate to something that hasn't been predefined by somebody else. So what Visicon allows you to do is just makes that all that 3D information that you have available in your team models available to everybody on a neutral, equal platform. So a lot of our clients tell us that we're democratizing the 3D model information for them. So for this first workflow, what are some of the tools that you need to be able to effectively open, review, and models? There's a viewing component. You may want to mark up. You may want to just simply cut new sections. You may want to run quantities, and you may want to measure. So all of those are integral tools that are part of the Visicon solution. So let's go through a quick example. I'm going to start the workflow on this project here. So we'll just call this Acme project. Typically, you would have started with REVIT as one of the components in your model. And once you install Visicon, you see that in all of your REVIT installations, it puts in a plugin. So here you see the export plugin. So just to save time, I've already gone through this process. So ETABS files, ADAPT files, point clouds, IFCs, they can be opened just by double-clicking on the files and opening them up in Visicon. When it comes to REVIT, you first go and somebody has to open up REVIT and create the Visicon version of that file. So I've already gone through that by clicking that export plugin, and we go here, and this is a folder where I've saved it. This is the REVIT model we're just displaying, so it's about 240 megabytes. And I want you to see that I've already pre-saved this file as a Visicon VXF file. I want you to pay particular note to how small that file is. That's less than 1 megabyte. Can you imagine how many minutes you're saving every single time somebody on your project team needs to query the information in that model and doesn't have to wait for REVIT to fire up and navigate, etc. So we're going to actually do that. So I'm just going to double click on this model, and you can see it instantly opens up that exact REVIT information. So now I can very easily navigate through the model. If I select any component on the left side, we've made it very simple and similar to REVIT. You have access to all of your project information at 3 levels. So this is generic information. So all beams would have exactly the same set of data, regardless of which model they're coming from. Under the Parameters tab, you have access to all of your REVIT instance data. And then under the Family tab, any information that is specific to how the object was defined as a family in Revit. So here you can click and you can see I'm now easily getting access to all of the different underlying modeling parameters that define this steel section. On the right side, I can come in and I can, isolate different component types. I can color code by material. I can color code by discipline, by Revit family. So there are lots by unique geometry. So there are lots of things that we do to kind of pre-package or pre-process the information for you. Let's go to the material color coding. And just to show how easy it is, let's say we want to cut a section here. I'm going to go ahead, right click, add a new clip plane. So now we've gone ahead and actually, can zoom in and out of the model. And we want to come in and let's say the architect is questioning us on the header height in this doorway. All we're going to do is go to our measure, clearance. We're going to create a new view and we're going to include all objects. And we can come in here and I can see that it's a 9.5 foot height. And if I'm interested in what's the width that's been modeled here, it's 6.917 actually, excuse me, there. And then I can come in and add additional markups. So we can do 2D and 3D markups. So we're just going to go through those like that, or I can come in and put a pen and mark it up. All of this allows you to quickly mark up and document your model information at once. So here this is our original view of the model. We're going to just delete that clip plane. And this is a new markup view that we've created. And I want you to observe that all other views that had been preset in the Revit model are retained as well. So that's just a very, very quick overview of what you can do with the Revit model. Now I keep talking about providing a standard approach across models. So let's put that to test. Let's go to that same exact project model, and we're going to keep coming back to this over the next, for the rest of the seminar. And so here you see, this is that same exact project. This is the ETABS file. So let's say I'm curious about information in the ETABS model. Guess what? It opens up in exactly the same format as my Revit model. I can come in here. We're going to I select the section. This time the parameters are defined a little bit differently. So here in ETABS, we have the actual sections, right? So it has more of the D, B top, B bottom. And so that's the same exact steel member. And I see that it's a section designation of W18 by 50. We want to make a section cut. Section cut is done exactly the same way, right? So this is how we go ahead and essentially allow you to view and navigate in your ETABS model identical to how you would do it in your Revit model. So let's go ahead and close this. And as a last step, what I want to do in this particular workflow is to highlight how you can merge two models. Because remember, I said one of the powers of Visicon is that it doesn't just provide you a uniform way of viewing each model independently, but you can also merge to compare. So let's do that. So this was our Revit version. We're going to go to File, Merge into Model. We're going to merge in a new data set. We're going to go to the file for where we've saved it. This is that ETABS model we were just looking at. I just open it. It asks, how do I want to synchronize my views? I'm going to synchronize all views. I've now inserted my ETABS model onto my Revit model. Under the Models tab, I can see that I have both models, right? So listed, I can also see them here. So this is my ETABS model, or excuse me, this is my Revit model, this is my ETABS model. I can give each one a unique color if I'm so inclined. So let's go to this color. We're going to now align them just so you can see how quick that is, right? Because maybe the person who generated the Revit model is tied to the project coordinates. The ETABS model is just randomly placed at 0, 0. So we're going to come here to the ETABS model and say align by objects. So let's start by taking this corner column from the ETABS model and align it with that corner column of the REVIT model. So we've now done a proper XY alignment. We see we're still off in the vertical, Z, no problem. We come in, we're going to do align by points. And what I'm going to simply do is take the top, I'm going to click the top of the uppermost ETABS model and click the top of the uppermost REVIT model. I'm going to zero out the X and the Y adjustment and accept it. It is that simple now for us to have aligned both of those models. If we go to the differential color coding based on model type, I can now add a quick clip plane. And as we go through, I can observe that, wait a minute, there's a discrepancy in my column placement. So here I'm off on my steel columns. So this interior column is well aligned. These exterior columns are off. If I come in and add another clip plane, here I can see, however, at this lower level, my columns are aligned. So in conclusion, from a model viewing perspective, Visicon provides a simple and powerful way for you to be able to view, review, markup, measure all of your project model types in a uniform and fast way. You can look at them independently or merge them. So let's go ahead and close this and continue on to next workflow. Okay, so the next workflow, if you recall, was how to standardize quality control with view templates. Yeah, and this is pretty exciting workflow. So first of all, let's talk about the building blocks. What do we mean by view templates? One of the building blocks are filters. So Visicon has a pretty powerful filter capability that allows you to set up any generic properties and expression. So a simple example that I'm showing here is just to identify all 10-inch slabs. Seems trivial, but you'd be surprised that not many systems can define this across model types or with any expression like you can write in Excel. The next building block are what we call validation rules. So think of them as more advanced filters. So validation rule allows you to configure models to highlight selected properties. So let's take that same idea of the 10-inch slabs and take it further. I want to identify 10-inch slabs, color them yellow, and isolate them. Again, this might seem like a trivial set of operations, but very powerful when you can string these types of commands together and apply it to any geometric or non-geometric property in your model. You'll be able to see how you can then quickly define standard ways of highlighting critical project information for you and for you to automate quality control steps. So we've defined filters and these rules. Now we allow you to group them, because let's say you've spent the time and in a coordination meeting, you identified certain things that are important. You want to repeat that set of rules and filters onto the next group. You're going to come in and you're going to define a template. We're going to say, this is our, Acme project template. And we're going to say filters A, B, C, and rules 1, 2, 3, all of those we want to keep applying to the next project without having to redo them. So we're going to define a template. Then the next project iteration model or another project, you just simply apply a template. So all of the rules and then the thought that you put into what you want to highlight can just simply be reapplied. So that sounds pretty exciting. Let's go through a scenario. So as I'd mentioned, we're going to keep working with the same exact project, Acme. I did something fun before today's session. I actually merged the REVIT, the ETABS, and I actually happened to have an ADAPT model on the same exact project. So I've already pre-merged those. And I want you to see that all of those merged is less than 1.5 megabytes. Imagine, again, this the speed and efficiency you're going to get in your office without having to chase down your, online this or that. It doesn't matter what your speed, the connectivity speed is or where you are. I want to now have a question about what is in these three models for this project. I just double click on the Visicon VXF file and instantly I'm in that project. So what I've done here is just to do something a little more fun is I've actually merged all three models, and I did it in 3 different ways, just to highlight what you can do. So what I've done is on the left side, I've actually merged and overlaid all of the models. So this left cluster is really just all of them. So what does that mean? So if I, for example, zoom in, and let's again do our clip plane. If I zoom out, and I know I've done level 2, I want you to observe that they're actually post-tensioning tendons. So here at that level 2, we're actually looking at the ETABS model, the ETABS columns, ADAPT columns, REVIT columns, all superimposed. That gives me great ability to check the consistency between models. That's all I wanted to highlight on the left side. Then on the right side, I've now isolated, and I said, kind of my procedure is, I like to throw all the models on top of each other because that's useful. However, I like to be able to identify certain things by looking at the models next to each other. You'll see in a second, if you superimpose too much information, it's hard to distinguish, some characteristics. So this is our REVIT model. This is the ETABS model, and this is the ADAPT model for level 2, right? So you see the individual post-tensioning tendons. So now all I've done in this model is just merge them. If we open up the project, right? So you see I have all of these individual models listed, no different than what we did before. And if I look at my rules, I have 0 rules. Because what I want to demonstrate is based on the principle that we just discussed, right? Filters and rules, how do I reapply them? So I'm going to go to File, Apply Template, and we're going to apply our slab and wall colorization template. What that does is it automatically applies standard slab colorization. So for example, this is colorize all slabs by thickness. This is colorize all 7.5-inch slabs, or colorize all 10-inch slabs, or 10-inch slabs. I can group these rules together. So this colorizes by thickness property. So what I want you to see is now I can instantly see and confirm in a project coordination meeting or present to my clients, look, we have consistently modeled. So the purple here, this is 10-inch slabs. We have consistently modeled the exact 10-inch slab in the ADAPT assumption, in the ETABS assumption, and the REVIT assumption. So these rules and filters apply universally to any of the underlying model types based on just the simple expressions that you're writing, and you only have to write them once. So here's colorize by thickness property, colorize slabs and isolate the slabs. So this might be a better way for me to isolate. And you can clearly see that the REVIT model has 2 slab thicknesses. My ETABS model does not, right? So that might be of concern. I'm isolating my shear walls. So here, this is isolating my shear walls by size, and I can see that I have consistent, thickness assigned to those. And here's by thickness type. So I can see that my ETABS, my REVIT have exactly the same change in shear wall thickness. However, I have some additional walls modeled in my REVIT model that are not present in my ETABS model. That's okay. And I have all of my openings and everything else seem to be similar. Again, on the left side, I've superimposed them. So here I can see the difference between, how the openings overlap, and then I can look at each one independently. So this is just one quick way to be able to use the apply templates across different model types. Let's go ahead and close this. And I want to conclude this session with one quick example using something a little more technical. So here I'm opening up an existing REVIT model. So this is an ETABS model. So this happens to be 2 merged separate ETABS files. Same idea. I'm getting ready for a coordination meeting. I have no rules defined. I'm going to go File, Apply a template that I've predefined. So this is going to be called Dual Towers QA. And what I have done is, ahead of today, I first applied this one. This is called Colorize by Slab Thickness. It just applies a unique color to each thickness. So this allows me to very quickly come in and browse thicknesses, right? So I can see where I have consistent thicknesses in my model. I can display slabs only, display walls only. I can colorize the piers, right? So these are the piers from the assignments based on the ETABS modeling. I can colorize and make the rest transparent, or I can just colorize and isolate. It is completely your choice how you want to define predetermined views that make your project coordination and quality control more effective. So here I can quickly see where I have changes in my peer definitions. As a project manager, I can apply this standard template now across any model, ETABS model that comes across my desk in seconds, and I can be much, much more effective. So again, colorize by material, and we're going to go, and you see here, I've now grouped two of these. So this is isolating shell elements for slabs by their thickness, isolating shell elements that are used for walls by their thickness, so I can quality control. So what I want to do is just show you how you can define one of these quickly. So we're going to open up the properties. We're going to go to one of these slabs, slab shell elements. We go into the properties, and I want you to see we have this property modifier M11. So this is what a structural engineer would use to modify stiffness or the amount of cracking that's going to be allowed. I want to do a quality control on this model. So I'm going to copy this variable. It's as simple as that. I create a new rule, right? So I'm just going to insert a new rule. It's as simple as just entering that variable right here. So you see area assignment, property 11, and I zoom out and I see, wait a minute, something is strange, right? I can see white is where it's defined consistent. And here, whoever, either there were two separate people or the same engineer, I see there's a different assignment on the same, what should be a continuous slab with the same exact structural properties. So I click here, I see this one is assigned actually this one we're checking. This is 0.25, right adjacent to it, 0.35. I can now fire up an email with an image of this model and try to get this resolved, because this should not be the condition. So in conclusion, you can use these standard filters and rules, visualization rules, to be able to define templates that are important to how your company wants to view information, and then apply those very rapidly to any new model iteration or new project models to isolate correct criteria that are important to you. So we'll go ahead and close this. Now moving on to the next set of workflows, we're going to talk about how you can use Visicon to manage model changes. Right, so this is a big headache for many of us, both in terms of internal model management and probably even more painful, having to digest and work on changes that we keep getting imposed on us by outside partners like the architect or mechanical, etc. So Visicon has 3 ways to make that easier for you. The first, and obviously it goes without saying that what Visicon does, that helps to automate and identify those model changes for you, so that you stay focused on what's important to you and aren't wasting your time trying to, go sheet by sheet or read the narrative of what is changed. So there's 3 ways that Visicon helps you. The first is called model compare. So model compare, the use cases, and it's essentially a very, very detailed data level audit of what's changed. So the use case is, I'm a project manager. I've just been presented with 2 sets of models. One of my team members comes to me and they say, look, I just don't know what happened with one of my ETABS models because the new one is behaving totally unexpectedly, and I just have no idea what I changed or what changed, because you might even have multiple people touching the model. So what we want to find out, what could have possibly changed between two models. So how do we do that? So this is the one instance where we actually initiate the workflow from within Visicon and pull in the models. All the other ones, we bring in the models first. So here we've opened up a blank Visicon. We're going to go to operations. So all of these model changes are under the operations tab. We're going to go to compare models. When we do compare models, and let me go to the right file, we're going to compare ETABS Tower A. So this is, let's say, the working ETABS model. And we want to compare it against ETABS Tower B. That's our latest model that's not working for us. When we run this, what it's doing in the background is it's doing a very, very detailed data comparison and shows us exactly what's changed. So here it's saying there are 7 objects that are only in model A. So in last week's model, we don't care about some of the high-level information. We see there's clearly one structural beam. So B59 was added or is now deleted, essentially, because it is not existing in today's model. And 2 walls were removed. At the same time, we see that a parameter here. So for example, we're looking at a structural beam was added. So what shows you what's added and what's removed. We have 4,566 components that are identical. And we have 9 objects that the program has identified that have changed. So let's see, if we open it up, it says material. We see that on the material, this parameter right here was changed from 0 megapascal to 0.09. Maybe that's important, maybe it's not, but this will identify any of those changes. Plus we can see we have 6 structural beams where in this case, the geometry has changed only. I click a different beam. In this case, the geometry changed. So, and in B77, the geometry didn't change, but the material changed. You see the material changed from C4 to C6. If I look at my structural columns, again, just material change. The geometry is the same. So this is an amazing tool that allows a project manager or the person actually working on their own model to investigate exactly where changes might have happened. You can either export the details into Excel, or what I like is just to importing them into my model. So this allows you to geographically, or not graphically, identify exactly where the changes happened. So you see identifying those columns that were affected. And if we open up the project browser and go to our issues, it is actually identified each component that's changed. So for example, this is one of those beams, and it gives you the details of exactly what's changed, right? So here material changed and the geometry changed. So powerful way for you to be able to isolate changes that may be affecting model behavior and you're just trying to isolate. So this is called model compare. Let's go ahead and close this. So the next type of change is called a variance check. So this scenario allows you, or this feature allows you to pinpoint where model versions have changed based on parameters you specify. So an example could be, you are working with your team, you've been trying to make the, the horizontal deflections due to lateral loads work, you're playing with different material assignments, you've gone through multiple iterations, and now at the end of the project, you're asking yourself, so what can we summarize exactly all the changes that we've made from version 1 to version 2? So we don't care about all those other changes or if geometry has changed. We specifically want to know if material assignment or the height of a column changed between 2 model versions. So we're being very, very specific. And so let's go through a simple example. So here I've already gone ahead and merged those same exact two ETABS models that we had just done, right? So the merging, I've already demonstrated how that works. Here you have ETABS Tower A, ETABS Tower B. Again, we're looking for material changes. It may be impossible for us to be able to see exactly where the change is based on the graphics. So what we do is we go to operations, we create a variance check. I've pre-configured the variance check, and I've set up 3 different ones. So the first one says material assignments change. So I'm saying, what am I looking for? I'm looking for a condition where the parameter I'm interested in has been modified. I'm checking model version A against model version B. And what am I checking? Core material name, right? So I've run this and it identifies 5 changes, and I've given the changes this color. So again, this is now highlighting only where those have changed. If I go under issues, I can isolate issues only. Oh, I see. Those are the columns or members that changed, right? It's that straightforward. If I go to the issue list, each one of these, in addition, it tells me exactly what the variance is. So that's one example. Let's go to the next one, which says component volume changed. So let's say my contractor only cares where are you increasing or decreasing volume because that's affecting my cost. I don't care if you change, location or anything else, but I just want to know how is it impacting volume. Same situation. We're checking model A against model B. And here, this time, the variance to show, right? Variance is just volume. And by the way, just to know how to find this, you just essentially cut and paste any of these parameters here are variables in the system. So you can use any of these things that use any of the parameters in any of the expressions or the search criteria and variance criteria that I'm showing you. So we're going to go to the issues. And again, here, this shows you how, for example, it's telling you that it increased this volume change from 46. It actually was it was a net increase of 46.6 cubic feet. So I can run this all in graphical reports or in tables. Then I'm interested to see, did my height change? I ran that based on the height, and I can see my audit comes out that I had 0 changes based on this criteria. So this allows me to kind of set up rules that allow me to find these changes. So let's close out of this and go to our last workflow example. So this last one, and I keep saying everything's my favorite, this one is really a true favorite, is called 3D Boolean Difference, right? So the first one, model compare, said, I have no clue what's changed, do a detailed audit. Variance check was, I know what I'm interested in, pinpoint those changes. This third one is, I want to see a precise graphical display of where the model geometry has changed. And what's important about this is this can be used across different model types. So the previous ones had to be a REVIT against REVIT or adapt against adapt version or ETABS against ETABS version because it relies on unique compatible component IDs, whereas the 3D Boolean is just checking 3D geometry. The use cases, I just received a new REVIT model from the architect. What changed? Yes, they've given me a narrative, but it's gibberish. It just doesn't make sense, and I don't feel like going through 100 PDFs and using Bluebeam sheet by sheet by sheet by sheet to see what do I need to focus on. I have 2 hours to direct my team where they need to make changes to our REVIT model or analysis models. So let's go through how that can be done automatically in Visicon. So we're going to open up a model. This time, we've taken 2 architectural versions of that Acme project. So the scenario here is the architect would have sent us 2 massive versions. These REVIT models were about 400 megabytes each. And I think this Visicon version is again, less than 2 or 3 megabytes. I just want you to see that, these REVIT models that the architect sent us has all kinds of garbage in it that we just don't really, as a structural engineer, let's say my scope is concrete, I don't really need to know all that other stuff. I just want to know, did the slab or openings or did walls move, right? So I've merged these two versions of the architect Revit model. So that's model version 1, model version 2, just superimposing them. It's just way too much information for me to be able to wrap my head around. So what I've done, and now I've gone through and I said operation. This time we're going to create this Boolean difference operation. Now to streamline the check, I've created 2 filters. So one filter says concrete elements. So I'm isolating concrete elements where I'm just simply saying the material that was modeled, used, or defined by the architect in their model is using that concrete, cast in place concrete. That's what I found in this model. So we're isolating, and so we're ignoring flooring and linoleum and all that stuff, but we're isolating concrete, and we're identifying walls. So we have these 2 filters that define what is important to me. I go to my operation. Here's the Boolean difference that we had set up. Just like before, we say model 1 versus model 2, but I want you to notice that here I'm constraining, so limiting my search to only concrete elements and walls, because I don't want to see if the lantern moved a little bit. I can give color code based on what's added, what's removed, what's moved, etc. And when I go into this mode, I've already pre-run it. You see there are 130 issues that have been identified. Instead of now flipping through lots and lots of PDFs, I can come in and I can quickly isolate. I'm looking for color, right? This is in the mode where I'm looking for color. So I can see, okay, this wall, green means that it's new mass in this newest version, which means the wall was pushed out a certain amount. Red means the slab edge was pushed in, right? So here you can clearly see where slab edges were added, removed, where the wall was shifted, right? So green means that it was shifted to the left, and it allows you to isolate exactly where the changes are in the entire model, one view or just with one view. If we go to issues and we only look at the results only, this lets me isolate exactly where the changes are. I can navigate the entire model and then zoom into those areas where I feel that the change is significant enough that it's going to trigger additional workflow or work requirements on my end. I have to update either my structural Revit or my analytic model. So that is the last example for the workflows. So in conclusion, structural engineers, and today's call was focused on how our structural engineers are benefiting from Visicon, are benefiting by improving their project outcomes. It's done because they spend less time finding model-based information. You're giving greater access to project model information for all project stakeholders. So again, internal team members, all the way from your summer intern, all the way to the executives of the firms, all are given the same standard way to view and understand and be proficient on the model and on an as needed basis. And it all leads to faster and better quality control, not only because you just have more easy access to the models, but you can also set up those templates that highlight characteristics that can identify hidden problems in your model that may creep into your 2D structural drawings without even knowing. So that is something that the color coding, our brains are very, very adept at being able to process differences in color patterns very quickly. And then lastly, everybody on your team can make more informed project decisions because we make all of that model information more readily available to you. So again, thank you for listening. And I realize I did run a little bit long. I apologize. I always try to keep things shorter, but if you have any questions for follow-up, either visit our website at visicon.com or email us at info at visicon.com. I will stay on the line right now and answer any questions that that the audience may have. And go ahead, you can just type those in your chat panel. Okay, I see there's several here already. Just give me a second. I'm just reading them. The first one says, can Visicon be used for non-building structures like tunnels? The answer is absolutely yes. You saw I pulled up the architectural elements. As long as it can be represented in REVIT, IFC, ETABS, we actually do a better job of displaying sections. I know some customers have pointed out one or two unique ETAB section types that we need to kind of fine tune, but in general, yes, it works across all 3D representations. Then it says, can we generate bill of materials as well as bill of quantities? Yes, we provide a very flexible quantity report capability. It just, to keep today's session short, I just didn't cover it, but the answer is yes. The next question is, can we have the recorded presentation? Yes, I will be recording, or this session should have been recorded, and I will distribute the recording when we're done. And let's see, there's a, okay, so there's another question is, you know, you're focusing on structural engineers. Is it used by others? The answer is yes. Today's session on purpose was geared towards showing models and the value proposition for structural engineers, but it is equally used by clients that are in pre-construction. I would say probably fewer architects at this point, but primarily structural engineers and contractors at this point. And not only general contractors, we have a lot of specialty contractors that are using the capabilities already. Perfect. So with that said, again, thank you for your time. I know I took longer than the 30 minutes. Again, I hope you see the value that Visicon provides, and please do reach out to us. You can download a free viewer on our website, and you can also request a full-featured trial if you contact us at the info@visicon.com. Thank you again, and have a great rest of your afternoon. Bye-bye.